Greetings of the day, dear students. In this class, we are going to discuss about the different problems on the losses and efficiency. Before entering into the problems, just I will recollect once again what are the all different losses we are having. Losses in DC machine, right? We are having copper loss, iron losses, magnetic or core loss, and mechanical loss. Again, copper losses, we are having armature copper loss, shunt field copper loss, series field copper loss, and in iron losses, we are having hysteresis loss, eddy current loss, and in mechanical losses, we are having friction loss and windage loss, right? So with respect to the armature copper loss, Ia square Ra, shunt field copper loss, ISH square RSH, and series field copper loss, ISC square RSC, right? And with respect to the hysteresis loss, WH equals to eta B max power 1.6 into FB, where eta is the hysteresis coefficient, B max maximum flux density in armature winding, F frequency of magnetic reversal, V volume of armature in meter cube, right? And also eddy current loss given by K B max square F square T square V, where K is a constant depending upon the resistance of core, B max flux density in Weber per meter square, F frequency of magnetic reversal in H, and T thickness of lamination in meter, V volume of core in meter cube, right? So with respect to the mechanical losses, we are having bearing friction, friction and windage losses, right? And sometimes stray losses equals to the iron losses plus mechanical losses. And here you can observe with respect to the efficiency of power stages, different power stages in DC generator, mechanical power input minus iron or friction losses will give you the electrical power developed in armature, EGIA, and also this electrical power developed EGIA minus copper losses will give you electrical power output VI. So mechanical efficiency B by A and electrical efficiency C by B, and commercial or overall efficiency C by A. In a given problem, if nothing is specified, we are supposed to calculate the overall efficiency, right? Eta C. So these are some of the basics. Already we have completed all these things, but just before entering into the problems, I have quickly recollected the basics, right? Now let me see the problem. Here, dear students, please observe a DC shunt generator delivers 195 amp at a terminal potential difference of 250 volt. The armature resistance and shunt field resistances are 0.02 ohm and 50 ohm respectively. The iron and friction losses equals 950 watt. Find EMF generated, copper losses, output of prime mover in kilowatt, and commercial, mechanical and electrical efficiency. So observe, dear students, this is the problem given, right? This is the problem given. Now he has specified here it is a DC shunt generator, right? So first let me represent the data given in the form of the some in the diagram representation. Let me draw a DC shunt generator. This is the armature shunt field winding, and the current generated from the armature is Ia. Number of times we have discussed this, and it is going to get divided into two parts: current flowing to the load IL and flowing to the field winding ISH. Now he has specified it delivers 195 amps at a potential terminal potential difference is 250 volt, right? Shunt field resistance is 50 ohm, right? Now current delivered IL is 195 amps, terminal voltage V 250 volt, armature resistance indicated with the letter RA, right? 0.02 ohm, and shunt field resistance RSH 50 ohm, right? So this is the data given, and also he specified iron and friction loss. How much it is? 950 watt. Clear? So up to here, this is the data given. This is the data given. Now we are supposed to find out the EMF generated, e.g. copper losses, output of prime mover, and efficiency. From DC shunt generator basics, the generated voltage Eg will be equals to the drop at the armature plus voltage available at the terminal. Eg equals to V plus IaRa. But if you observe the current generated from the armature, right? If you apply KCL at this point, Ia is some part is going to the field winding ISH, and other part is going to the load. So Ia equal to IL plus ISH. But what about ISH? V, terminal voltage V divided by shunt field resistance. V is given 250 volt divided by 50. So in the shunt field, a current of 5 amps is flowing, and line current already gave you in the problem. How much it is? 195 amps. Now from these two, what will be the armature current? 195 plus 5, it is 200 amps. 200 amps. By using this Eg equals to V already given 250 plus Ia. Just now we have found out Ia 200 into Ra. This is already given. Armature resistance is given. So we will get 254 volt. 254 volts. This is the EMF generated. Clear? Right. What is the next step? Total copper loss. So in the given DC shunt generator, you are also having the shunt field and armature copper losses. Both we will have. Right? So total copper loss is given by armature copper loss plus shunt field copper loss. Ia square Ra plus ISH square RSH. Ia we have derived 100 into 0.02 plus ISH 5 square. ISH square 5 square into 50, and we will get 2050 watts, 2050 watts. And the stray losses, it is already given 950 watt, right? Therefore our total losses will be equal to the total copper loss plus stray losses. If we add 2050 plus 950, we will get 3000 watts. 3000 watts is the total loss, right? Now the output power is given by terminal voltage into current drawn by the load, VIL. Output power V into IL. 250 is already given, 195 is already given in the data. Therefore output power is equal to the 48750 watt, 48,750 watts. Now for any given system, right, here we are having the input, and we used to get the output. Now there will be some amount of losses here, right? Our output is nothing but the input minus losses overall. Our input is nothing but the output power plus losses. Therefore the input power will be equal to 48750 plus 3000, and we will get it as 51,750 watts. 51,750 watts is the input power. Clear? Right. Now if you observe the different power stages, see here the overall output is 48750 watts, and the copper losses are 2050 watts, and the electrical power developed EGIA is 50,800 watts. Iron losses is 950 watt, and the input power 51750 watts. From these different power stages, Now we can calculate the mechanical efficiency is the ratio of B by A, right? That is nothing but the electrical power at armature Eg Ia whole divided by mechanical input power. We will get it as 98.16%. Electrical efficiency C by B, electrical power output divided by electrical power at armature, and it is nothing but 48,750 divided by 50,800, right? So it is 95.96%. Now commercial efficiency, overall efficiency eta C equals to C by A, that is nothing but 48750 watts divided by 51,750. It is 94.2%. 94.2%. So this is how we can calculate the efficiency and different losses from the given data, right? So dear students, I repeat again, the moment you see the problems in your question paper, please don't be afraid, right? First, try to attempt the problem. Don't think that for the answer itself you will be awarded the full marks. No, for the data given, procedure, formulas, all those things itself you can get the some minimum amount of marks, right? So please practice the problems where you can score or get the more marks. Okay, yeah. Now let me see one more example, dear students. A shunt generator gives a full load output of 5 kilowatt at a terminal voltage of 220 volt. Armature and field resistances are zero point 0.5 ohm and 50 ohm respectively. Mechanical and iron losses together are 500 watt. Calculate the kilowatt input required at the driving shaft on full load, and also calculate efficiency. Clear? Right. Now first let me write the data given. The names of the variables are important. Most of the times where the student feels difficulty is from the data, from the problem given, what are the proper variables to be taken. For example, output power 5 kilowatt, but how do you understand that with respect to the DC generator? It is the power output. What should be the formula? That should come to your mind. That point should come to your mind, right? The moment the formula comes to your mind, it will be easy for you. Indirectly, this 5 kilowatt is equals to the V into IL. Now the terminal voltage 220 is given. Which variable you have to take, whether it is V or EG? That point should come to your mind. EG is the generated voltage or generated EMF, but the terminal voltage is V. So you have to use the variable V. Armature and field resistances are given. Armature resistance RA, that is the variable we have to use, 0.5 ohms. Shunt field resistance RSH, that is the variable we have to use, 50 ohm. Mechanical and iron losses 500 watt. Now what is the input power and what is the efficiency? That is the those two are the parameters to be calculated, right? Yeah. Now observe, number of times we have discussed this point. What is the input power? Our input is nothing but the output power available plus losses, total losses. But what about total losses with respect to the DC machines? Yeah, we used to have armature copper loss, shunt field copper loss, and stray losses, right? Yeah. Now the stray losses are already given, 500 watt. It is already specified. With respect to the DC shunt machine, right? If this is the armature current IA, and if this is the current drawn by the load IL, and some amount of current goes to the field winding ISH, if you apply KCL at this point with respect to the generator, IA is nothing but IL plus ISH. IA is nothing but IL plus ISH. This is important. This thought should come to your mind. Now what about ISH, shunt field current? Our terminal voltage divided by shunt field resistance. It is simply 4.4 amps. Now what could be the power drawn by the load? Once you know the power and once you know the terminal voltage, then it gives you the current drawn by the load IL. Why? Because power is nothing but VI. VI divided by V will give you the current drawn by the load IL. So in this context, the power output is 5 kilowatt. Please don't forget to take 10 power 3 kilowatt is there. This is where most of the students are going to commit the mistake. Simply they will write 5. So we have to take 5 into 10 power 3 whole divided by terminal voltage is 220. So the current drawn by the load to 22.72 amps. Now already we have calculated ISH, IL is known. Now armature current IA equal to IL plus ISH, IL plus ISH. Clear? Now it is equal to 27.12 amps. So what about total losses? IA square RA plus ISH square RSH plus these losses are already given 500. So 27.12 square into RA is already given 0.5. ISH square 4.4 square into RSH already given 50 plus 500. You will get 1835.74 watts. 1835.74 watts. That is the amount of total losses. That is the amount of total losses. Now from our basics, from our previous basics, what is the input power? What is the input power? Output power plus losses. Output power plus losses. So 5000 5 kilowatt 5000 watts plus 1835.74 watts, we will get 6835.74 watts. What about efficiency? Output power by input power. Output power is already given 5 kilowatt whole divided by input power we have calculated. So its efficiency is 5000 divided by 6835.74. It is 73.14%. 73.14%. Clear? Is it okay? Right. So this is how we have calculated the efficiency from the data given. We have calculated the losses. We have calculated the efficiency. I repeat again, in the exams, don't be afraid of the problems. Be confident and you can attempt the problems. Right? Yeah. One more example. A 220 volt DC shunt motor takes 5 amps on no load. Armature and field resistances are 0.5 ohm and 250 ohm respectively. Calculate efficiency of a motor for a load current of 40 amps. For a load current of 40 amps. Very simple. Please draw the diagram for your convenience sake. Draw the diagram of a DC shunt motor. Observe at this node point with respect to the shunt motor, it will draw some current. Current flowing to the armature is IA and flowing to the field winding is ISH. Right? Whereas if you recollect with respect to the generator, it is generated current IA. Out of this, some current will be going to the load and some current will be flowing to the field winding ISH. This is for generator. This is for motor. I hope you understand the difference. If this step goes wrong, entire problem goes wrong. This is the key point. IL equal to IA plus ISH in case of motor. IA equal to IL plus ISH in case of generator shunt DC shunt. I am speaking with respect to the shunt, right? Yeah. Now, without any load, the current drawn is 5 amps. Armature resistance 0.5 ohm. Field resistance 250 ohm, right? Load current, if load is applied, if load is drawing 40 amps, then what will be the efficiency? Clear? Right. Now, what is the formula for efficiency? Output power by input power. We are familiar. What about output power? Input power minus losses, whole divided by input power. But what is the input power? At 40 amps load, the terminal voltage is 220 VI, V into I, 220 into 40. So this much power is the input, 8800 watts, 8800 watt, right? Now, what will be the losses? We can write it in terms of two parts, constant losses plus variable copper loss. Observe in the problem, the no load data is given. Now, this no load data will be useful to calculate the constant losses. What about ISH? V divided by RSH, it is around 0.88 amps. Armature current, IL, the current at no load, the current drawn under no load condition, I or I naught or some IL minus ISH. This is already given 5 at no load. This much amount of current is drawn. Now some current is flowing to the armature and some current is flowing to the field winding. At this context, I want in current drawn under no load, I it will be equal to IA plus ISH, right? Yeah, from that IA equal to I minus ISH, like that we got this. Don't get confused, right? Yeah. So 4.12 amps. Now what will be the armature copper loss under no load condition? All this will be useful to calculate the constant losses. IA square RA, IA is just now we have calculated. Keep in mind all these are under no load condition, without any load, right? Yeah. 4.12 square into RA, 8.48 watts. Now input power, this much current is drawn under no load 5, but the voltage is already known 220, so 1100 watts is the input power. Now what will be the constant losses? Whatever the no load input power minus armature copper losses at no load will give you the constant losses. Very important. If you understand this point, then this problem won't go wrong. Most of the students will face difficulty to calculate this constant loss. Once if you are familiar to calculate this constant loss, you will this problem is very easy for you. Clear? Right. Now constant losses equals to no load input power minus armature copper loss at no load. So 1100 watts minus 8.48, it is around 1091.52 watt. 1091.52 watts. Clear up to here, dear students? Right. Now, with the help of load, if the load is present, if it is drawing 40 amps, now what will be the armature current? I minus ISH 39.12 amps. At that time, armature copper loss IA square RA 39.12 square into 0.5, 765.18 watts. Now what will be our total loss, constant losses, which we have found without any load, plus armature copper loss at load, right? So 1091.52 plus 765.18, it is 1856.70 watts. This is the total loss. This is the total loss. Now what is our efficiency? Input power minus total loss divided by input power. Is it okay? Output by input. Output we can also write it as input minus total loss divided by input power 8800 minus 1856.7 whole divided by 8800, so 78.9% is the efficiency. 78.9% is the efficiency of the motor. Clear? Right. So this is how to attempt the problems, right? We have seen all these examples on calculating the efficiency losses with respect to the DC machines, right? So dear students, I request you to share this app, or to share this application or the link of this course to as many students as possible, right? Most of the students, irrespective of the most of the engineering branches, whether it is a CSC or IT or mechanical or civil, triple E, or most of the students are having this subject either in the first year or second year, depending upon their curriculum. But we have designed the course keeping all most of the colleges syllabuses in mind, right? So definitely this will be useful to the most of the students. Please uh, try to make this course to reach as many students as possible by sharing the link, right, with in your class groups or with friends in other colleges, or to your seniors who are having this subject as a backlog. Because I have told you that only 55 to 60% of the students are getting passed in the first attempt. Most of the students are getting failed in this subject, right? So please share this application with your friends, right? Thank you.